Okay, starting. I'm just waiting for the transcriber. Yeah, okay, it's started. So, hi everyone, and good afternoon. Hope everyone is having a good day. Hope everything is good on your side. So welcome to the first session or tutorial session of the day of day 2. I think this is going to be a super exciting session because it's a very exciting or interesting topic for me, at least. So yeah, as usual, if you have any questions, if there's anything that's not clear, or if my audio is not clear, or so on, you can just raise your hand or just open your mic and speak. So my audio is clear, right, guys? Just to check. Good, thank you for the confirmation. Okay, so yeah, let's talk about what change point analysis really means. So I think the point or the name itself is implies what it does or what it is and what it's supposed to do. So it's just analyzes change points. So it just analyzes where or the point where change occurred, right? So so the name is actually self-descriptive, but to just dive a bit deeper, so it's just identifies or analyzes the point where the statistical property of the time series changes. It could be deviation from the mean or the deviation between the mean and the point. Like when I say deviation, of course, there will be deviation, but huge deviations, that will be statistical property change, and like huge difference from the variance and so on and so on. So it's just a way to analyze or to identify points where the statistical property of a time series changes. So we call these points breakpoints or structural breaks because it's basically breaks the structural property or the statistical property of time series data, basically. Yeah, so it's basically used to determine the number of changes and their place or location, their precise temporal location, and it helps actually. It doesn't directly analyze the impact. Of course, it does analyze the change it had, but yeah, I think you can say it analyzes the impact as well. It doesn't analyze the cause. That's what I wanted to say. So by using change point analysis, you can identify the number of changes from a given time series data. You can find or locate the precise location or where that change occurred, and of course analyze its impact. So how did it change the statistical property of the time series data? So of course there is some key distinctions from outliers. So we know outliers. Outliers are some, like from the data that are different, very different from the given data. So like change point analysis is different from that because it does it focuses on the change in statistical property other than individual outlier. Rather than the individual outlier. So it focuses on sustained fundamental transformation in the data characteristics. So it's basically focuses on the statistical property. While outlier most of the time is a single often transient deviation, like a single extreme stock price, a single extreme height, or a single extreme age, or something. So it focuses on a single thing, but while change point focuses on the long run or change in the time series property, change in the time series property, statistical property. So yeah, that's I think this word actually really defines it very well. Like it's a sense a shift, a sustained shift indicating a new region or state. So it doesn't after the pain point state actually changes or the statistical property changes. So that's why it's different from outliers. So is that clear, guys? Just to be on the same page on the definition on what it is that we're going to be doing. Okay, good. Yeah, if you have questions, please ask. I'm just going to chill up on you guys like this. But yeah, so why do we use, or why is it important, like you using change point analysis? So the first can change point analysis be applied to non-time series? No, it has to be non-time series data, because how are you going to identify the change point, the location? Plus, what kind of data do you need? Okay, maybe you can write. If you can't speak, you can, by the way. But if you cannot, you can type. Yeah, so not only should it be time series, it should be also continuous. So yeah, so like the one in the most part is to uncover structural changes or changing the statistical property of the time series data. So it will reveal where, sorry, when, because it's a time series data, and how data generated mechanism involved. It detects this events, so that's what you're going to be doing for this week. So it helps you to detect events that actually triggered this change in the time series property change, and it will help you segment the time series. We will also see this one. So by using this, you can divide the data into homogeneous intervals for better modeling and forecasting, so that you can account for the model results. So when your model result comes in, you can actually tell why that result came by depending on the change point analysis, because you would divide the data into homogeneous intervals. It enhances model accuracy. That's what I just explained. It accounts for shifts, leading for more robust productive models. So, and like this also, well, part of what you're going to be doing for this week. It will enable you timely interventions, so it will facilitate quicker and more informed responses, because by using this model, you can say you can actually predict what's going to be coming, or help you to have a well-informed decision making. Yeah. So of course we do have a lot of different types of properties. So the main ones are mean shift. So this is a huge change, or sometimes it's a gradual change, but most of the time it's a huge or absurd uh, change in the average value of the data. So when there is a huge gap between the data and the average value, that's called the mean shift. So this could be a new marketing campaign that leads to a sustainable higher average daily sales, but that their daily sales is not going to keep on rising. Eventually, it's going to go down. So, but that time after the campaign, when you see a surge or an increase of daily sales or the sales value, that's called mean shift. For the variance, it's the same thing, but change in the spread. So it's more of a spread fluctuation or volatility of the data. So yeah. So for example, increased economic uncertainty causes prolonged period of higher volatility in the country's inflation rate. And trend. So trend. You. I don't know if you remember, but last time we have checked, we were checking. We have seen. We have actually. Sorry, what was the word? We have seen three parts of a time series data, right? A trained, like quick place where there's a quick shift, and the hybrid one. So trained is for a prolonged time. So a change in overall direction or slope of the time series. So trains tend to go high or in low, but not in a short amount of time, but in a longer amount of time. Yeah. So the adoption of any technology can cause the growth rate interest of usage to accelerate. So of course it's going to take time, but once it takes time, it will not go down for a long time. So it's trained. But variance or fluctuation is the other part of the time series, right? Maybe you can refer to that slide as well. And frequency changes, so changing predicable or cyclic patterns. So cyclic patterns are short-term trends, right? So trends are for a long term, but cyclic patterns are for more of a short term. So I think we have seen in the last section, I think we have seen the sales of sweaters. So the sales of sweaters, we can see it as cyclic or frequency shift, because when it's summer, it could go up, but when it's winter, it could go up, but for other seasons, it could go down. So that cycle repeats itself many times throughout the year, right? So climate change alters the timely intensity of seasonal rainfall pattern and so on. And other statistical shift in autocorrelation, distribution, shaping, etc. So the main ones are these four. So when we look at methodology of change point detection, you can basically set up your change point analysis methodology in two ways. The first one is offline, which is what you're going to be doing for this week. You have the entire data set on your hands, and you're going to be analyzing the historical data to identify past change points. So which is what you're going to be doing. So this is called post-event analysis. So it will help you identify long-term trends because most of the time the market repeats itself. So it will help you in that way. It will help you with having an insight into what happened, what caused what, and so on. And for the online, you will receive the real-time data. You will work with, or you will process with the real-time data and detect changes as soon as they occur. So this is a highly level. Of course, it will require a lot of data engineering and so on, but this is what normally is being used in trading and so on. So it's real-time processing, monitoring, immediate response system, like for detection, anomaly detection, and so on. Sorry. So is that clear, guys? Before we move on to the tools to check change point detections, is that clear? Okay, good. Okay, that's good. Thank you for the confirmations. So let's see some approach that helps us, or that will help find or identify these change points. So the first part is the cumulative sum. So I think, as the name actually implies, the purpose is to detect changes in the mean of the data series. So if the mean changes dramatically, I think we have seen it from the mean change. I think if you take a look at, or if you remember this one, we basically are going to identify the mean shift. So it detects changes in the mean of the data series. So how does it do? So it accumulates the deviation from the target mean, and if there is a change or a huge change between this cumulative sum and the data point, it will identify that point. So of course, this part I just wanted to include it because it's part of part of the statistical approach. But for this week, this part is not going to be usable because the cumulative sum is good for identifying single or very few change points, but it's very less effective if you try it for multiple change points, which is what you have, right? If you have looked at your current data set, you can find out that it's not it has a lot of change points. So one example of this usage could be monitoring the average weight of manufactured items. So this could show you if there is a shift from the mean weight. Yeah, and the second one is print extract linear time, or PELT. So the PELT is we will see it actually what we're going to be using. It's very flexible and it's really good. So it has high efficiency algorithm to detect multiple change points. So it's good for your case. And for the mechanism, it minimizes the cost function because the data is homogeneously with segments. So it's going to have segments for each. It's going to have segments for each homogenic sections or segments, plus the penalty for how many changes you want to see. Plus it has, so it's very versatile, so you can use a lot of, like for instance, you can use for the facility, or you can use L2 for mean change to identify the mean changes, which is what you basically are going to be doing with the cumulative sum method. And if you use RPF, you would see the mean or variance or distribution change, shape changes. So it's very versatile, and its linear time complexity is 0 of n, O of n, sorry. So we will see what the penalty means. So as the penalty goes up, the number of detected change point go down. So this is a very critical point to remember, because if you let it do it by itself, I will show you an example actually. It will have a lot of change points, and that's not going to be easy for you guys to see, or like to get insights from. So one of the examples could be identifying multiple distinct periods of growth or declines within the company's quarterly availability and so on. So basically, it will help you identify multiple change points. And another very interesting point or very interesting method is the binary segmentation method. So what it does is it uses recursive method to find multiple change points. So this is very interesting. So it finds most significant change points in the whole time series, and then it will recursively apply sub-segmentation. So it's going to create segments and segments between the change points, and it will also recursively apply sub-segments to that segment as well. So it's very fast, but it's very less accurate, and it doesn't guarantee an optimal solution. So yeah. So one example is segmenting a long time series data of a measure sensor data into different operational states. So from the change point, you can understand. So when the first change point comes, it will segment, or it will detect the higher change points. So it will have normal, stressed, and faulty. And then from these segments, you can actually recursively do the change point analysis, so that you will find from the normal state what are the change points, from the stressed state what are the change points, and from the faulty state what are the change points. And the last one is likelihood ratio test. So just to compare the likelihood of data under different hypotheses. So no change, or does it have a change or not, and so on. Yeah. So is that clear, guys? Before we move on to, of course, actually, I think I have noticed that we're going to have a session on Bayesian approach. So I'm just going to have just a highlight of what it's going to be, because you're going to be taking a look at it in detail in the tomorrow's session. So before we move on, is it clear, guys? Okay, I have one. Yes, Nuri.
So thank you. Since it's a new concept, I may ask some ridiculous questions.
No question is ridiculous. Yeah.
So this Bayesian change point detection method. Look after building the model and find the change on in 2010, and I have events in 2011 or 2010. So finally, it will show me the event is here and the change is here. But will it really tells us that the event impacts, I mean, the event impacts that change point, or it's just correlating or associating the event point and just the change point?
So yeah, like what you have asked is actually related to the project, not to the session. But let me just answer it. So what you have asked or what you have pointed out is, does the Bayesian actually telling me the impact, or how like how big was the impact of that event, right? So basically for this week, you have like the price of the oil, right? Plus you're gonna get, or you're gonna extract, or you're gonna search through Google or by using LLM the events that occurred uh, on change point. So what we are taking a look at right now is the money in the middle, or like you have the change point, sorry, you have the price rate, and you have the events. But the events are a lot, and the price are a lot. Very big data sets. You cannot relate to everything, right? You cannot relate every event to every price, because there's a lot of news, and there is a huge data set for the price. So here is where the change point analysis comes in. So the change point analysis is going to tell you where the huge changes occurred, right? So by taking in those points, those dates, it will tell you the date and the like the date where the event occurred, or the change occurred, and you will take that date and search on Google or by using LLM in order to get the events from that date, right? And then you will do the correlation. And coming back to your question, actually the Bayesian change point detection does tell you, especially the PYMC, I think. Let me check, I think. Yeah, PYMC library actually tells you the impact as well. So yes, it does tell you the impact by detecting how, like, what was the variance before the impact or the change point, and what was the mean before the change point, and what is the mean and the variance after the change point, and it will tell you the impact by calculating between them. So is that clear? So we're talking about the money in the middle. We're talking about how we can detect these change points. So is that clear, Nuri?
Yeah, it's clear. Okay, one more question. On the task, it says we have to identify more than one change point. I think the task is saying it's just a single
Yes,
point
because
change.
no, the task does it say single change point?
I understand like that somewhere on the task. What is that?
No, like okay, like we will see actually in the example, but it has a lot of change points, right? That
Yeah.
you cannot have a single change point. It does say that. If it does, I will correct it. Okay, so I'm waiting for your confirmation of it. Okay, anyways, I will check it. I don't think it says that, but if it does, it's a mistake, and I will
Yeah,
correct it.
from the task. Okay, it says define switch point TAU. This is the unknown point in the time where the data's behavior change. Define it as a discrete uniform pair over all possible days in your data set.
Yeah, so switch point. So I'm talking about change point.
Mm-hmm.
So maybe let's go to like this like the practical session, and I think it's going to be very clear what we're trying to do with the change point analysis.
Okay.
So if it is not clear by then, we can have that discussion again.
Okay.
Yeah. And thank you for the question, Nuri, as well as always. Yeah, so let's take a look at. So as I've told you, like the Monte Carlo method, you're gonna be having a session tomorrow. So I'm just going to have just an introduction to it. So I will not go deep into it. So it's just the bijunction for detection method. For this case, I'm going to be using the PYMC library. Uh, sorry, yeah. We'll use the price theory. So as I've said, you're going to be having a detailed look. So that's why I didn't include it here to update the probability of change point given observed data. So it will provide a full post rear distribution of change points, location, parameters, and so on. Plus, it will also give you a probabilistic statement like there's a 95% probability that a change will occur between the date A and B and so on. And the role of the Markov chain Monte Carlo method here is to get the distribution are often complex and cannot be solved analytically. So we will use the Monte Carlo method here. So this algorithm is going to draw samples from this complex distribution and enable the characterization of the shape, the central tendency, asymptoticity of the distribution, and will help to make the Bayesian inference practical. Yeah, so some key takeaways are like change point analysis is very important statistical method for discrete temporal dynamics. It will help you to precisely identify fundamental shifts in the time series, which will help you distinguish them from the transient fluctuations. And it's very critical across finance, environment, public health, and some frameworks such as the Bayesian framework provides you with a very good understanding of why the change happened and when the change happened. And of course, lastly, it will help you quantify impacts and produce or provide confidence interval for timing. And so it's very interesting and very important thing to know, especially if you are going to be working with time-based data. Yeah, so I think that's it for the slides. I will add some differences. I think I already have them. But do you have any questions? That's it from my side for the theoretical part before we move on to the practical. Do you have any question or is it clear? Okay, good. Okay. Sorry, let me just change to the let's refresh this one. Sorry, I don't know why, but it's taking a bit longer to load. Sorry, just a second, I think. Okay. Okay, here it is. So can you see my screen? Good. So here, actually, I used the same data set that we have given you. And last time I have noticed that a lot of people were having issues with the time series data, especially with the data format. So that's why I wanted to use the same data as well. So here we're going to be using for the change point the paired for you for the paired change point detection method. We're going to be using the ruptures uh, package, and for the Bayesian we're going to be using the PyYMC package. Okay. So like I've said, I'm going to be using the same dataset that we have provided you with the Brent oil price.csv file. And here I just loaded it and transformed the date. I used the format mixed. So if you find it hard to do, so just make sure to have the format to mixed. And then, so for the non-value, so this is a very simple cleaning process. So I didn't do a lot of digging into the cleaning process. I just wanted just to have the non-values removed, because if you have non-values, it's going to be bad for the the change point analysis. So I just used interpolate. I just interpreted the price, the non-values for the price. And if there is still non-values after the interpolation, I'm just going to drop them. And so for the Bayesian, I think tomorrow, of course, you're going to have a detail into it. So for the Bayesian method, it's very good to have the log values or the log returns of the point data. So for that, I just used the log value of the price. And if there is a none, I will just drop it. Okay. But for the for using, so I'm going to be using this for the Bayesian, so for the PyYMC. But for the other one, I'm going to use the real data. Okay. So I'm going to have the time series price for using the rupture method. I'm going to use the real price. And for the Bayesian method, I'm going to use the log return. Okay. So here you can see the price actually, like the first 5 rows or 6 rows of the data point. You can see it, and here is the last 5 or 6 data points of the data. And here is for the log return. Okay. This is the log return of the same data. Okay. So let's talk about the first method, which is paired or by using ruptures. So here you can see, sorry. So here you can see what I did. So so I just reshaped. So the first thing that I did was I have to reshape them and change them into a number array. Instead of a time series, I'm going to change them or convert them to an array. And then I used here L2. So if you remember, you have multiple methods in order to find, like here I'm going to find the mean, but if you use RPL or RPT, I think you can see the change in the variance and the distribution shape as well. But here I just wanted to see the change in the mean. So I just used L2. So here I just initialized my ruptures. So I just used the module and so on. And for the penalties, just parameters that controls the number of detected change points. So normally it's used, it's good to use the 3 times the logarithm of the length of the dataset. But here you can use whatever you want. So so this is where you're gonna have to do some change. So most of the code you can reuse them, but here for the penalty you have to change them. I will show you why. So I just used the recommended 3 times the logarithm of the length of the dataset, and I used that as a penalty. So higher penalty results in lower or fewer number of change points identified. But so you have to play around with the penalty in order to get the sweet point. Yeah. So here's just it's going to, if there is a rupture change point, it's going to just, this is so when you specify the number of change points, especially like let's say you wanted to identify 3 change points, so by 3 is going to change, it's going to identify 2 using the time series data, and the last one is going to be the last part of the time series. Okay, so you can exclude the last one. So is that clear? So if you try to identify 4 change points, the fourth one is going to be the fourth one that the model is going to detect is going to be the last point of the change time series data. So you can remove that one. Okay. So if it is the last one, you can remove it. But if it is not, you can use it. So here it will tell you the number of the indices. So by the indices, so since we have changed or converted the time series data into an array, you're gonna have the index of that, like, or the place where the change would occurred. So it's going to tell you that, and then here is just going to plot the change points. So yeah, here you can see so the change point indices. So here you can see rupture. Sorry. So here you can see the date, and here you can see the price. So you can see how like the change point detected indices, which is just the point where the change point occurred, and the date where the change point occurred. So after doing this, so right now what you can do is you can just take this date and go on Google and search what happened on this date or around this date that could affect the the uh, the market or the price of an oil. Like, so here it's going to help you. So having this is going to help you. Like on the second one, you can just go ahead and use this to search what happened on this date or around this date that affected it. And this graph, if you can see it, so it's a lot of change points it has detected. So you cannot even count. Plus, I think if I go here and if I scroll to the right, you can say you can see it's a lot or like humongous number of change points that it has identified. So this is not ideal. So this is why you need to play around with the penalty in order to get like to the sweet spot of the number of change points identified. So normally by change points, what we mean is if there is a change, a slight change in the it might not be slight, but if there's a change in the time series data, so here you can see there's a change. So it has identified this point. So let me zoom in. So it has identified this point. Sorry. And there's a change again here. It has identified it. It has changed over here. So it has. And so if there is a shift in the characteristics of the data set or the time series, is going to identify it. So that's what we mean by change point analysis. So is that clear, guys? Before we move on to the Bayesian change point detection. Okay. What about the rest? Is it clear? Good. Yeah. So here, let's talk about or have just discussion or just an example, an introduction to the Bayesian method. So I just include it because you're gonna need it to identify change points by it too. But like I said, you have a detailed session as well. So here, like if you remember, I have said that I'm going to use the log return of the price instead of using the real price because it's very better for it. Yeah, sorry. Okay. So here I'm just defining the model. So from the PM models, I'm going to define the Bayesian model. So it's going to help me identify prior to the change point location for uniform over the time series data, and you choose the discrete uniform description. So you have a lot of methods in order to identify this, but I have used the discrete uniform distribution to identify the index of the change point. So prior and after, you will have prior and prior and post change. So priors of the standard deviation and before and after the change point, I will see like the effect of it. So we can use half normal distribution, but they must be positive. Okay. So here I'm just defining just making them use the normal return. So assuming that the mean of the log returns is constant or around zero or so on, because I can assume this because I have used the log return instead of the real data. So I can use a very small normal prior around zero, which is often reasonable for log returns. But so here I have used around y0 and the sigma 0.1. But if you use the real data, these points could change. So I'm gonna here is just plotting them and finding the results. Sorry. So here is just the number of rows. So it's going to have samples from them. So the number of rows it have and the scaling, if it has scaled, it has range, the divergence, step size, the graduation evaluation, and so on. So I think you will see what these things will mean. But sorry, let me just get a yeah, sorry for that. So yeah, here I think the graph actually is better. So here you can see the probability of the most probable change point index. So here is what we mean by switch point. So here I think Nuri, earlier you were asking for, if you are asking for one change point, it's just the switch point or like the most probable change point index. So you can find it by doing this, by using the Benjamin method, which is what we have done here. So instead of having the very multiple or change point analysis on every change point, you can use this in order to find it. So here you can also see the date and so on. So here you can see the more probable change point in the time series data and so on. So let's see the interpretation. So this is just interpretation of what you have seen, right? Okay. So here, what I wanted to show you is how we can make segments as a change point. Green line, yes. So here, in this case, this is the most probable change point where the model has. So in this case, the model has concluded that this is the most probable change point where the most probable change point occurred. And it has given you the data and so on. So you can take this and see what made the model detect this point to be the most probable change. But yes, it's a change point. Sorry. So here what I've done is I have created multiple segments by using ruptures, and it tries to identify their impact. Okay. So here for the first segment, I have from 0520 up to 1987. You can see the mean price is the standard deviation in the price. And the second one is you can see it has dropped the mean price and the standard deviation price, and you can see the change, the percentage in change and how much it has affected it. So here you can find what happened between this time that affected the price in negative 5.65%. And yeah, and here you can see from 1988, like April 8th up to like 1988, the 6 month 09, it has actually increased, dramatically increased from -9 to positive 10. So you can also find what happened that triggered this change and so on. So here is just what I mean by creating segments, and from those segments, trying to identify that. Sorry, someone failed. That's why. You can identify what's caused it, and the impact of it. So this is what I was talking about earlier, Nuriye. So here from this point, you can just see what happened that affected it to be this. So here you can see there is a big jump from $19 to $27. So there is a big jump from the previous segment. So you can identify what happened there that triggered it and so on. Yeah. So since we have identified a lot of segments or change points, so the segments are just points or time intervals between the change points. Okay, just to be clear. So that's why we have a lot, but you can, like I've told you earlier, you can just play around with the change penalty and try to identify the optimal number of change points and work with them. So this will help you communicate the events and their impacts as well. Yeah. So is that clear, guys? Good. So for the Bayesian, here, since it has only identified one point, of course you can play around with it, and like I think I have commented on the code where you can change in order to find more than one change point, and you can do the analysis for that change point as well. So here you can see from the overall what is the mean log return, and from that log return we have identified the change point, right? From the change point, what was the like standard deviation before the change point, and what is the standard deviation after the change point, you can see. So you can see why it has identified that point to be the change point, because it has a huge change. Yeah, so this is one way you can communicate it. So yeah, any questions? Or is that clear? If it is clear, show me some thumbs up and we can end the session actually. Yes, Nuri.
Sorry, I was interrupted in the middle. So
Okay.
I saw you are using Rapture.
Yes. Is it from my side or did it just come or did it stop? Can you guys hear me? Okay. So I think Nuri, I think we have lost you.
Am I here? No?
Yes, yes.
So you are using Rapture, right? In the
Both Rapture and PYMC.
Okay. So, but I saw you find that multiple change points using Rapture, right?
Yes.
And when you use PYMC, you have get only most probable
No.
changes. That is
No. Like, so what you have to understand is there are multiple, like for the Rapture, like there is penalty. So penalty is one of the parameters that you will pass. So in order to identify in order to tell the model how much change point you need. And there is the same parameter in Bayesian or the PyYMC, where you can manipulate to give you multiple change points. So here I can make the Rapture give me only one change point. It's not from the model, it's from the input. Yeah. So is that clear? Maybe.
Yeah. So it's possible with PYMC, that means.
Yes.
Okay, thank you.
So thank you guys for thank you for the question, and thank you everyone for joining. And if everything is clear, if it is not, you can reach me on Slack. Discussion. So thank you so much, and have a great day. Bye.